Okay, students, so a question we're going to look at here for a few minutes is what do you do when you're presented with what looks like a bunch of randomness, right? Our brains seek out patterns, right? So like it says at the top, you'd probably start to identify like, oh, there's common colors, maybe there's common sizes, and you'd start grouping things, you'd start coming up with some sort of pattern. So the first thing that leaps out to me is just common colors. So I might say I'm going to put the reds together and I'm going to group the blues, and these pinks are the same color and these dark blues are the same color, right? You just do this naturally, right? And once you do this, you might decide, well, I don't like this pattern. I kind of like that there's big ones to small ones, and so you'd start working on it farther, right? You get the idea. Well, what are we trying to represent here? How does this matter in our topic of chemistry? Well, if you imagine all the different elements that we know of, right? There's 118 different elements, different kinds of atoms. And how do we organize those? How do we decide, like, there's a random names that we give them? Is there further information about this? Well, in the late 1800s, there was a guy by the name of Dmitri Mendeleev, and he ordered atoms based on atomic mass. So he started out with the smallest and ordered them up to the biggest, not in size, but in atomic mass. So imagine the size of these boxes actually represented the mass of the box. So we might reorder it something like this, just going from smallest to largest, right? So this is going to take just a moment here to get it all right, but we're going to see something that appears once we do this. Okay, so we've got them ordered from left to right there, from smallest to largest. And again, remember that Mendeleev in this late 1800s, he's ordering the known elements at the time, which there was only about 63 known elements at that time, from the smallest atomic mass on the left up to the largest one on the right. He wrote them out by name. Now what he started to notice here was, just like you might notice in this list of boxes, that there were some repeating trends, right? Like a red box and then another red box, and then a blue and then another blue. For Mendeleev at the time, that would be behaviors, right? So maybe it was that this was an element that was a gas, and then all of a sudden again an element that's a gas, or an element that's a metal, or an element that's really reactive. So what Mendeleev decided to do was to turn this into a two-dimensional pattern, right? So red, blue, kind of light blue, pink, dark blue, and then red repeating again. So he decided to bring that down as a second row. Okay, all right. So what you might notice here is that all of a sudden there's kind of more pattern, right? You've got reds lining up with reds, these light blues, and so Mendeleev started thinking, well, I wonder if there's not this color blue here, but maybe there should be. So I'm going to leave space for it. I'm going to line it up so that colors, or again for atoms, these were behaviors, were lined up vertically, and see what happens, right? So after this dark blue, you'd expect a red, but there isn't one in my list. You'd expect another kind of this bright blue, but there isn't. So now we're going to go light blue, and then, oh look, another pink, another dark blue. All right, so we'll line these up nicely, and we'd expect a red. There's a red. Then, hey, here's this bright blue that we haven't seen for a while, so let's scooch things over, give space, right? And what you start to see is that there's a two-dimensional pattern to what seemed pretty random at first, okay? So again, what Mendeleev did was the same thing, but with atoms. He lined them up by atomic masses, and he started noticing that there were these common trends. And Mendeleev even left spaces, and he predicted that there would be elements that would fill in these spaces, like this blue, bright blue box, one that would be a heavier than the red, lighter than this kind of blue-green, and would have a blue trait, right? And as we move forward in time past Mendeleev, these other elements were discovered that actually fit into these spaces, that had the mass heavier than this one per se, lighter than this one, and had the same kind of trait as these ones, right? So what we see here is really the birth of the periodic table, right? So we're going to look over here in a minute at the periodic table and how that shows these different trends. Okay, so here we have the modern periodic table, which is based on these beginning things that Mendeleev set out. You'll notice that instead of ordering them from left to right based on atomic mass, they're ordered left to right based on atomic number. So 1 proton in hydrogen, and then 2, then over 3, 4, 5, 6, 7, and so on, all right? This is very similar to what Mendeleev had laid out, but atomic number of protons, since it defined the element, was a better way to order these. Now, again, Mendeleev's key idea was instead of one big long string of smallest on the left to largest on the right, he turned this into a two-dimensional table by matching up properties, things that behaved similarly. So we'll talk later about how like this whole first column has similar properties and the second column has similar properties, and like this final column on the table is called the noble gases, right? But again, the groundwork was laid by Mendeleev, who noticed this repeating pattern. And another way to say that would be that there were periodic traits to all the elements, which is essentially why we call this the periodic table, right? That it can be laid out in a two-dimensional fashion because of the periodic behaviors that we could line up in these two-dimensional ways. Okay, a couple other details here. You notice this block at the bottom that's set off by itself really would go in this little spot here. Notice that all these light blues are all metals and all the oranges are non-metals, and then there's kind of this odd sort of metal category, right? And it's interesting how they all group together, right? Well, these are just further patterns that we see when we order these things in the right way. So again, that's just kind of a basic idea of why the periodic table looks the way it does. It's to reveal these deeper patterns in the elements.